unfortunate, sad, whatever way you may call it, but we have to live with it. And I welcome you all to this new subject, which is mechanics of human body. Now, this subject is a research-based subject, okay? And it has another name, actually, a shorter name. Probably you might have come across the subject called biomechanics. But when I introduced this subject long back, more than 10 years ago, there was already a subject called biomechanics offered from the civil engineering, although the content was far less. But since there was an existing subject, biomechanics, I could not sort of put the name of the subject as biomechanics. So instead we put it, from mechanical engineering, we put it as mechanics of human body. But essentially it is biomechanics. Okay. So I hope most of the students are aware of the subject biomechanics, because it forms an integral part of any mechanical engineering department across the leading universities of the world. Can everybody hear me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Now, let me share the slide, which
Yes.
just let me open the slide. Just a moment. That slide I had already shared with you. That is called Mechanics of Human Body. That's the first slide, okay? Oops. Something's... Wait a minute. It's coming, it's coming, it's coming. In my house, actually, there are too many users of this internet, and that is sometimes causing problems in the speed of transmission.
Sir,
Yes.
sir, we are hearing some clock ticking sound from the background.
Oh, yeah. Well, the clock is ticking. So it is quite sensitive, actually. Okay. Now I will share this slide. So I go to the slide share mode. Can you see everybody?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So I'm going to the slide share mode. Yeah. So the first slide is the subject, mechanics of human body, and it would be taught by myself. I'm professor at the Department of Mechanical Engineering. My research area is biomechanics. Okay. Now, In this class, I will give you some overview of this subject. As I told you that it is essentially biomechanics, and biomechanics is a subject which is in principle interdisciplinary in nature, because we are applying mechanics to solve problems in biological system. Okay, so it is a subject that seeks to understand the mechanics of the living system. Of course, it's the human body. So we will apply the principles of mechanics, advanced mechanics, whatever you may call it, solid mechanics, fluid mechanics, and we will be actually solving problems of the related to the human body. That's a biological system. Okay. Biomechanics often tries to understand mechanics of some movements of animals. Okay. And that sometimes is helpful in giving solutions to certain problems. Okay, or flock of birds, the mechanics of flock of birds, how birds fly, snake algorithm, things like that, many sorts of weird things we try to learn from nature, and we try to apply it in appropriate areas. But essentially, we would be learning the basics of biomechanics. Can everybody hear me?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Because these are initial days, so I will sometimes ask you. Sebi is there? Sebi?
Yes, sir. Yes, I'm here.
Okay. Yeah, Sebi is my PhD scholar, and Sebi is the teaching assistant who will be assisting me in this subject. And he knows more about the operations of Microsoft Teams rather than me, because he has already attended classes, so he knows the pros and cons of different aspects of Microsoft Teams. I'm getting used to it. In the last year, I used actually Google Meet and WebEx and all these things to finish the last 1 month of the course, but now it is Microsoft Teams. Anyway, let us get back to the subject. So biomechanics helps us to understand the relationship between structure and function. So if you try to realize that how you walk, for example, okay, the walking cycle, or the gait cycle, G-A-I-T, gait is basically walking. So if somebody tries to understand how we actually walk, it is a highly complex set of mechanisms of musculoskeletal systems that give rise to this movement. Okay, so there is a very intricate relationship between structure and function in each and every constituent element of the body. Okay, so we would try to understand precisely the relationship between structure and function. Function means mostly movements, okay, and movements of different kinds, various range of movements that gives rise to sort of that offers basically different activities that we perform in daily life. So biomechanics helps us to understand the relationship between the structure and function. It can predict changes due to alterations. Now, when you have a problem, say you break your leg, or it is quite common in middle-aged or in old age that you fall down and you break your femur. You probably have heard of femur neck fractures. And in those cases, you have to intervene. A surgical intervention is required, and an alternative sort of device known as implants, or you have to do certain tricks that would restore the normal movements of, normal movements in the body of a patient. Okay, that may be also in form of a, that may be also caused by traumatic injuries. If you encounter any car accident and you damage your basically the knee joint or the hip joint, it requires surgical intervention to restore normal movements. So biomechanics can predict changes due to alterations and propose methods of artificial intervention. When I say artificial, it is of course something from outside. Okay, it is not natural, so it is in form of a surgical implantation or surgical intervention. Okay, therefore, diagnosis, surgery, prosthesis are very closely associated with biomechanics. Okay, so you have to diagnose, like a diagnostic center, what is the problem. It may be also in form of offering solution to a sportsman even. Say there is a subject called sports biomechanics, and once upon a time I was in Calgary, and there was a laboratory called Laboratory of Physical Education. Okay, and it was in the University of Calgary, and Calgary at one point of time held the Winter Olympics. Okay, that was in Canada. And they had a physical education laboratory closely associated with biomechanics research. And they were trying to quantify the contribution of different muscles in certain sporting activities, like say skiing, for example. Take, for example, 100 meters dash, okay, in Olympics. So if an athlete has some deficiency in a certain muscle activation, okay, he or she may not be actually he or she may be trying to reach a desired output, but it actually hinders, the deficiency in the muscle actually hinders the athlete to reach that outcome. Okay, but that first needs to be diagnosed, and then certain exercises, certain activation in the muscles can be offered so that the performance of a particular athlete can be enhanced. We in India, perhaps now these sort of things are coming, but long back, maybe 20 years ago, 25 years ago, these countries were actually supporting the athletes in a very scientific manner. Okay, so diagnosis, surgery, prosthesis, all are closely associated with biomechanics. Now, as we continue with the overview, the next slide, we have just to show you some examples that most vigorous development of biomechanics, although it is called biomechanics, but the most vigorous development of biomechanics is associated with orthopedics. Okay, because the most frequent users of the operation theaters are patients with musculoskeletal problem, various type of musculoskeletal problem. Okay, so musculoskeletal problems means the problems associated with your structure and movement, structure and function. Okay, it may be rehabilitation, it may be an accidental case, by which your structure has been damaged, so the natural structure that is existing is damaged, and you need some surgical intervention to restore the normal movements by any means. So the word biomechanics is mostly associated with orthopedics. Okay, and in this class, we would be actually concentrating on the various aspects of orthopedic biomechanics. Biomechanics of trauma, injury, and rehabilitation. Rehabilitation, there is a subject called rehabilitation engineering within biomechanics. Okay, and that is slightly different from what we will be actually discussing in the class. Rehabilitation engineering is something to do with orthotics and prosthetics. So that is artificial limbs. Okay, it in a way it is similar, that it offers movements to disabled patients. It can start from a polio patient. It can start from deformity by birth. It can actually be offered to soldiers whose limbs have been affected in warlike situation, combat situation. So many things, but that is an external device, an external assistive device that helps somebody to actually restores normal movements to a great extent. May not be entirely, but to a great extent. So biomechanics, trauma, injury, rehabilitation is becoming increasingly important in modern society. The pictures that you see here are actually from my as outputs of PhD scholars who has worked in our laboratory. You can see that on can you see everybody? On the top right hand corner, we have CT scans. From CT scans, CT scans? Everybody knows CT scans. From CT scans, we are trying to actually do some modeling here. So we have CT scans, the top, where I'm pointing my arrow. So I'm identifying the hip bone. I'm focusing on the hip bone, which has a femur and the pelvic bone, you can see clearly. And from there, I'm isolating the femur, and then from different views, I'm trying to reconstruct slices of the femur or the pelvic bone. And you can see on the right the 3D model of the pelvic bone. Okay, the top right hand where my arrow is, you can see the slices that has been used for reconstructions. So very closely packed slices, which defines the contour of the bone, and then we actually join these slices to form the 3D volume. Okay, so this is a very basic example of modeling and simulation that we actually do in our laboratory in the department. Parallelly, we also have done a lot of testing to validate our simulations. And one of the example is testing of this hip, you can see, with an implant. We are applying actually loads from the top through a mechanism designed and fabricated here. And this is basically done as a part of the UK-India collaborative project. So we have been using an implant. You can see that the femur bone has been implanted. The shiny surface is the implant. And then we are applying the hip joint force and trying to measure few parameters that actually would validate the the finite element results. So validation in form of experiments of different sort of modeling and simulation has been undertaken for years in our laboratory. Now, from most, why are you doing this subject? Why specifically this subject? Okay. It is important to know that many students, I know that for the sake of doing the subject, they are doing it. They don't find a time slot. There are quite a few who has opted because there is no other alternative to fit another subject. But let me tell you very precisely that the fundamental research has included not only surgery, prosthesis, implantable materials, and artificial limbs, but this subject extends over to cellular level mechanics. So cellular and molecular aspect of healing, fracture healing, even healing of soft tissues as well, not only hard tissue like bone, for healing of soft tissues like muscle, tendons, in relation to stresses and strain that is generated within the body. Okay, it moves into tissue engineering of cartilage, tendon, and bone. You probably nowadays hear that there are efforts to regenerate cartilage, okay, grow cartilage in the laboratory, and then where in patients the cartilage has been eroded, they actually put these cells so that the cartilage is regrown in certain region of a patient. Okay, so this course will cover the fundamental aspect as well as the state-of-the-art techniques of modeling and simulation, and is intended towards engineers, scientists, and clinicians. So there has been record that many doctors also have done this course from the School of Medical Science and Technology. There are postgraduate courses where from the doctors came, and they learned many things. Of course, the course is offered by mechanical engineering, and we discuss the principles of how this mechanics can be applied to solve different problems of the biological system. So this course is designed for MTech PhD students essentially from mechanical, civil, biomedical engineering, and to some extent to the medical students who have a special interest, who are likely to be benefited by learning the fundamental aspect of modeling simulation of musculoskeletal system in order to pursue advanced studies and research in the areas of biomechanics and biomaterials. Okay? Now, in my course, since I am a mechanical engineer, and mostly, I think all the students are from our department. Is there anybody from outside the department? Hello? Hello?
Yes, sir.
Is anybody outside the department?
Sir, I'm from aerospace department.
Okay. Okay. So you know the solid mechanics principles. So basically, yeah. So you are from aerospace engineering. Are you undergraduate student or a PhD scholar?
Sir, undergraduate.
Undergraduate. Okay. So since all the students are already aware of the principles of solid mechanics, advanced mechanics of solids, so we will be actually applying all these principles to solve different problems or having a more clear understanding of what is happening within a biological system. Okay. Now, essentially, we will be embarking upon a whole new world, which is the biological world or the human body. Okay, so we first need to know the biological system of the human body, in particular from the perspective of a mechanical engineer. Okay, we are going to study few classes on anatomy, physiology, and movements, structures, movements. It may be a little bit off from your usual subjects or topics that you encounter in mechanical engineering, but that is essential. So first few classes will be dedicated on musculoskeletal system. Okay, and you might actually come across quite a few clinical terms, but you have to know the biological system on which you will be applying the principles of mechanics. Okay, so please don't get a little bit bogged down by coming across some system biology type topics, but that is essential. Without that, you cannot understand the language of biomechanics. Okay, so let me just discuss the modules, the major modules of the course. Now you can see that we start with musculoskeletal systems, so and try to identify or rather discuss with you the clinical problems, the common clinical problems in orthopedics. We will be revisiting the concepts of stresses and strain from the perspective of biomechanical problems. Then we will enter into gait analysis and joint kinematics. Okay, this is where actually hardcore kinematic analysis of each and every joint, hip. Mostly we will focus on, we take the case of hip, but we will also discuss hip, knee, shoulder, and elbow. Okay, so these four major topics will be covered in principle before, say, if this was a offline class within the campus, physical classroom, then this is up to, the red line is up to which we will have before mid-sem. Okay, and the topics below the red line will be discussed after mid-sem. This is the 50% of the course, and the 50 is after mid-sem. So then we move inside bone, so mechanically behavior of bone or bone and joint mechanics. We'll discuss about joint replacements, concepts of implant design and failure mechanisms, and then we will be going into tissue engineering current concepts. So how bone grows, cartilage grows based on the principles of stresses and strain. Okay, what is the effect of the mechanical rather the mechanical signals in form of stresses and strain in bone growth or other tissue growth like cartilage or granulation tissue. So any specific questions on this module? So this module is tested, and we have been, the content is already taught for years for the other students who have passed out. And remember, as I was telling you all, that we need to fill up the student details, the Excel sheet that has been uploaded. Please do it as soon as possible, because I need to add all of you in the Google Drive, Google shared folder, which is which has the name Mechanics of Human Body. So the instructions is that shared folder Mechanics of Human Body is created, already created in Google Drive, and that contains presentations and scientific documents as supporting study materials. Okay, there are a lot of resources within that. And, till date, many ex-students who have passed from this institute and working as PhD scholars abroad, they still refer to that, and they still want that, sir, don't remove me from this folder. There are many resources which are really useful. Okay, so last year student also, when I actually cleaned up this, the members of the shared folder, they started complaining. Anyway, so it is a very useful site. I mean, shared folder, so that I can add you all to this. The lectures, the PPT of my lectures will be available there as well as supporting documents. But let me tell you one thing, that this subject requires a different sort of effort from your side. It is not a very conventional subject. As I told you from the very start, it's mostly a research-based subject. So you have to read papers, you have to discuss with me, and it is not a really conventional subject, straightforward subject, that I present some equations and you simply put some values, you solve or solve some equations, find out unknowns. It's not something like that. There are many associated things. There are things from the biological world, there is things from the mechanics world. So together, it is essentially a research-based subject. Okay, so it requires a lot more participation of the students and a more matured sort of effort is required from the students to learn this subject. Okay, I cannot run around with a stick in my hand and chase the students and say do it, do it, and do it. Okay. Now, since we are in this online education mode at this moment, so we have continuous evaluation, which will be based on, say, assignments, major term projects, short tests, and major tests. Okay. Now, I would like to draw your attention regarding this major term project, and this will be on kinematic analysis of the musculoskeletal system, say maybe a hip joint, and this term project has to be submitted as groups. So the group has to be formed by you. You have to choose your partners, okay, and it should be 4, maximum 4 in a group. Okay, so we will be also having short tests. So maybe we can have a short test and then some major tests. Okay, so that probably we will take the help of the Moodle platform to have some short tests, but the term project is very, very important, so that you actually discuss together and come up with a project report based on which you will learn the musculoskeletal kinematic analysis. Okay, and maybe later another term project on the second half of the course. So thank you for your attention and listening. If you have any question, I will be more than happy to answer that. I have to, sorry, I have to. Oops.
Hello.
Yeah.
So can you give us tentative dates when these term projects and all will happen?
Okay. Firstly, can you see me now? Is it or still the
Yes,
slide
sir.
is?
Yes, sir. We can see you.
Okay. So slide sharing is off now. Term projects actually will take some time for you. Okay. It is in form of a project report. Okay. And the initial sort of part of the course you have to devote on understanding. We will give you some information, links, also documents from which you have to learn how, say, you find out musculoskeletal forces, for example, in a hip joint during a particular activity. Okay, so there are a host of muscles, there are joints, different joints, and how you actually apply the principles of inverse dynamics to find out the different unknowns, right? So initially, it would not be possible for you. Say the month of January would go in learning the subject, the initial part of the subject. Then slowly when you get into the thing, I would give you sufficient time, because you see, it is important for you to learn the techniques, and learning the techniques would require some time in this field. Okay, it's not very straightforward. So maybe a month. Is that okay?
Yes, sir.
But you have to form groups, okay? And submit the project in form of a PDF file. And
Okay.
this has been very well appreciated by students, earlier students, ex-students, because they actually got that confidence or they got a feel of what is this subject all about. And remember that you will be applying the principles of solid mechanics or advanced mechanics of solids, whatever, kinematics, everything, and then you will be really solving some problems related to human body, which actually comes out to be quite interesting. Okay. Hello.
Yes, sir.
Yes, sir.
Yes, sir.
So this slide is uploaded already. I hope, let me just check. But it should be in the.
Yes, sir. It is visible in the files tab.
It's still visible?
Yes, sir. It's in the files tab in the class materials
Yes,
part.
sir.
Yes, it should be there. Yeah. So you can also talk directly with the TA, Sebi, who is my PhD student. Any further question? Hello. Any more questions?
Sir,
Sir,
does this
how
course
many
also
tests
entails the?
will be there in this?
Yes. One at a time, please.
Sir, how many tests will be there in this semester?
How many do you prefer?
2 or 3.
Major, I think 2 tests has to be there. Okay. Major, we
Yes,
have
sir.
to, there are certain academic norms. Okay. I have to fulfill that. I'll try to keep it, based on the recommendations of the academic norms. I'll try to keep it minimum. Okay. But I have to conduct a minimum number of tests, right? That is
Yes, sir.
recommended by the academic council. Okay. So I cannot deviate from that. But
Okay, sir.
you see, a lot of effort in this subject particularly is required from student perspective. Okay. Because here you can actually apply all the principles in solving real life problems. Right. It is not a very straightforward subject like mechanics or fluid mechanics or engineering mechanics or thermodynamics, something like that. Okay. And there is a lot of material available within that mechanics of human body folder. I think students who would like to learn this subject will get a lot of benefit by accessing that folder. Perhaps you are all aware of this subject, biomechanics, in all the leading universities of the world. Anything else? But I have seen that, just a moment. The number of participants in this class is 107. So I'm downloading the attendance list for this class now. But the number of registered students is 120.
Excuse me, sir. Sir, I have been attending class today, but I have not yet been registered officially. So I'll be doing that today. So my name won't be in the registered list.
Okay, but you have to do it because
Yes, it will be done by today.
no further students. It's already crossed the limit. 120 is a very, very large class.
Yes, sir.
Same for me, sir.
Yeah, all students who have not yet done, please, it's already 120 registered students. So you are not in the ERP list.
Yes, sir. My name is not yet registered, sir. Because of other slot clashes and constraints, I have not yet registered in that. So today it will be done. So you'll find my name there.
Okay. Sebi is there?
Yes, sir. Yes.
Could you download the attendance list?
I can't download because you have started the meeting, so you have only the permission to download.
Why it is?
Can
I'm
you
clicking, but
can you try to switch off your video? It's over. No, I mean not the on top. The camera.
Okay.
Yeah. And you may stop sharing the content. Left of the leave button. Yeah.
Yeah.
Now you may try to download the attendance list.
Yeah. One file download. Great.
Okay.
Oh, so many tricks.
I think it's because of the internet connectivity.
Yeah. And I have too many clients in my house. My daughter is a first year student and she's also using, my wife is teaching, myself is teaching. So we have too many. When did it vanish? Downloading. Says downloading. One file downloading. Downloads. Today, oh my God, there's so many downloads. Okay, it's already 10:51. Let me check which one has the highest number. ठीक है. So all is well, right? Hello.
Yes, sir.
Yes, sir. Yes,
Yeah.
sir.
So no further questions. So we can stop recording. Stop recording.